Good morning, everybody. It is going to be a challenge for me to follow George Clooney and Analysts Without Borders and you know, the tragedy of Syria and sort of come back from those examples back to the world of infrastructure. So just like Ray and Ted talked about this morning, I'd like to talk to you about physical things, the places where geospatial technology is being applied, can be applied, and will be applied to help people imagine, design, and create a better world. I work for a design software company called Autodesk. Many of you know us better through our products like Revit, AutoCAD, Max, and Maya, but I'm not here really to talk about the products. I'm really here to talk about how the world of physical infrastructure design and engineering needs to change and is actually already changing. So, you know, I think the impetus for, let me see if this thing actually moves, yes, for changing anything, you know, it's always anchored in the sort of the context of what's really happening. And as you all know and probably participate in, the world needs infrastructure. It needs a lot of infrastructure. Everywhere you turn, emerging countries, developed countries are all engaged in this challenge of building a world that can handle not just the 7 billion people we have today, but the 9 billion that we're going to have by 2020, the 11 that we will have a few years later, on and on. And that requires addressing how we move them, how we house them, how do we find energy sources for them, how do we address issues relating to urbanization? You hear this, you know, you all are part of this world where you hear statistics of the things like China is building 15 cities that don't exist today, each of which will have millions of inhabitants and do that in the next 10 years, as is India, as is so many other places around the world. By some estimates, the world needs about $60 trillion worth of infrastructure right now. Okay? And the ability, though, for the world to create that infrastructure is far, far less than the demand. And it's not just, you know, frivolous demand. It's actually what the world needs is 60 trillion. But by some estimates, what we can put in place right now is about $24 trillion worth of infrastructure. And there are many, many reasons for the gap between the demand and the ability for us to meet that infrastructure need. You know, and you can enumerate this, and I'm sure you're part of many conversations. You can be, you know, conversations relating to legislation, population concerns, environmental concerns. Certainly money is a huge issue. We all live in I live in the United States where we are still recovering from the economic recession, as is our parts of Europe, of course. And, you know, certainly there's so many considerations in terms of changing that equation, changing that balance, changing the shape of the curve between the demand and the supply of infrastructure. But the question I'd like to pose to you this morning is whether technology itself is one of the challenges that comes in the way of capacity and our ability to meet that infrastructure need. That is the selfish point of view I bring to our conversation this morning. I am not saying that the other issues aren't big and that the other issues aren't significant contributors and that technology is the solution to all the problems in the world. I'd like to think so. But obviously it's one part of the solution to the problems that we have in the world. And in fact, just now from Steve, you saw a very compelling example when you see the images and you see the way by which we could all crowdsource and look at what's going on in Syria. That was just not possible 10 years ago. And that's a great example of how technology can be applied to solve or to address or to put pressure on an issue that 10 years ago, none of us would have thought technology could be applied. That's Syria and others is the domain of governments and foreign policy people, not us human beings, who sit here in a room and think about our daily lives. But technology can be a game changer in many ways. And if you think about the world of technology and its intersection with infrastructure, the world of GIS has been around now for 30 years, something, give or take a few, depends on your point of view of when it all started. And it has done many, many great things in the world of infrastructure. And I'm, again, going to restrict myself to those things that human beings build. GIS, of course, continues to be applied in so many ways, from analyzing crime and population and environmental considerations. But in the world of infrastructure, it has played a really important role, especially around planning. It's helped people understand, like the example you see here on screen, as to what will be impacted, who will be impacted, how will they be impacted by a piece of infrastructure that is being planned. And we are grateful for all its abilities and capabilities that it has brought to bear all these years. But I'm here to challenge whether the first generation of GIS technology is sufficient to meet the needs that we have today. It has certain limitations that are getting increasingly apparent. So the first generation of GIS technology, or whatever the current generation of GIS technology, requires expertise. Expertise means that information is not freely available. The very fact that organizations have a GIS department is a problem, because information wants to be free. Not free in the sense of money, but free in the sense of consumption. Okay? Now you imagine if while driving a car, for you to be able to use GPS-based directions, you had to call a department for access to information. Okay? But that, in fact, is the situation, unfortunately, when it comes to the world of infrastructure. That the people who are engineering or designing these pieces of infrastructure are often divorced from the context in which the information exists. So you have these information islands, you have all this rich data that has been collected, but is mired in the world of expertise, while design and engineering that's making critical decisions about where things are going to be placed, how they're going to be placed, are working in a different context, often in exclusion of that information. So what does that lead to? It leads to constant change, not in a good way, not at the front end of the process, where people are including the information, in the sense of looking at constraints and trying to solve for those constraints, but really towards the middle or end of the process in a very disruptive way, where once the design and engineering groups have laid out a plan, then they discover that they're driving the road through a zone that was not, that had to be excluded, or they were creating environmental concerns. And this leads to huge issues, cost overruns, time overruns, that contribute to that gap between the $60 trillion demand and the $24 trillion supply. You may think that's a trivial example, but it happens all the time. I live in San Francisco. We have a US 101 corridor that has been planned through you. I drive every day down that road. I know this. That has been under discussion for close to 15 years. That has been revised and re-revised and revised again, because every time the engineers come up with a solution, they discover a new condition that they're violating, or they run into opposition from what in the United States we call NIMBY, not in my backyard. That you can build whatever you want, but not in my backyard. And they have a hard time engaging those constituents. So information is a big deal. It is a big part of the challenge people have when they're laying out physical infrastructure. The other challenge with the first generation of GIS technology is that it's kind of dependent on an old architecture. The geek in me has to say this. It's dependent on CPU limits, and you start reaching the limits of those technologies, of PC-based technologies, as you go by. They are becoming more powerful, but they're also sort of focused on the wrong end of the problem or the wrong end of the solution, where really the computing power is moving increasingly to the cloud as opposed to the endpoint devices. And so we are hitting those limits in terms of what CPUs can handle. 50 petabytes of data, as Stephen showed. Those are not things that you load on PCs, but those are things that you'd expect the cloud to compute for you. And these limitations of information and computation are happening at a time when projects are getting bigger. Around the world, infrastructure projects are getting bigger and more complex because population is becoming larger and more complex. And so you have an enormous amount of complexity that has to be managed. You have teams that are getting larger. Okay, so when we talk about teams, historically, people think of teams as the group of people inside a company, or maybe even the contractors and subcontractors, and maybe some agencies that are involved in the project. But as I said, increasingly, the people who are the public participants on a project are becoming more and more important in the success of the project itself. What do hydroelectric dams have to deal with? They have to deal with the villages that get flooded or have to be displaced, population that has to be moved, roads, bridges, tunnels. Pick your infrastructure project. They constantly have to do a good job communicating to the impacted citizens as to why something will be better, why something will be different. So really, teams are getting larger. So projects are getting larger, teams are getting larger, and to build on what Steve said just now, the data is getting larger. Because the data today is not just images, it's not just CAD models, it is sensors, the whole thing, the concept of the Internet of Things. There is information coming from everywhere at all times. You saw an example of remote sensing. There are sensors being built into buildings, sensors being built into roads, sensors being built into phones. Every car now, with its GPS device, can contribute information back to the world, assuming that you get that user's permission. And as you can see from the social media examples that I have up there, there's this Israeli company called Waze, spelled with a Z, that Facebook is now chasing. And they have this entirely crowdsourced way of delivering traffic information. You can get traffic information from sensors, you get traffic information from people. You have Google glasses that are going to take photographs every 5 seconds as you walk around. How much information is that going to contribute? Laser scanning is becoming ubiquitous. So the amount of data that is being made accessible is really exploding. So if I would posit to you, we're heading into the curves are going the other way. GIS 1.0 is heading towards a set of limitations. At the same time, while projects, teams, and data is heading the other direction, it's becoming bigger. And so we are, and I would assert this, need a fresh look at how we apply geospatial technology to the world of design and engineering or infrastructure. I'm not an expert on how that might be applied to the world of crime or forensics and environment, so I'm not here to say that GIS in its old form is not useful for other things, but certainly for the world of physical infrastructure, we need a fresh look. And in fact, I would say that what we need is no GIS. And what I mean by no GIS, just to the people out there who are getting ready to throw something at me, I mean not only GIS, okay? And what I would say that the second generation or third generation of geospatial technology for the world of design and engineering really requires is something that combines GIS with design information, with laser scan and point clouds, with social information, with sensor information, and makes sense of it in the form of an information model. I would just, for the sake of simplicity, continue to refer to it as information modeling for infrastructure. We use the word building really to describe it not as a noun, as a building that exists, but as a verb, the act of making a piece of infrastructure. And so I'd like to assert that the second generation or the third generation, depending again on your point of reference, of what we need to do for the world of physical infrastructure really combines all those pieces of information and makes it accessible in a host of endpoints or consumption ways, especially using mobile devices for informing the participants of a project, using the cloud for computational purposes, and certainly using social networks in order to connect all the participants in the project. And so that idea takes the world we are in today, where all these things exist in islands, where things are really thought of as databases, where you're really looking at things as sort of discrete events, where you ask a question and get an answer, where you're looking at things at a level of megabytes worth of information, where things tend to be static, and turns that on its head and really turns, instead of looking at things as GIS or CAD, really creates data. I mean, when you look at the web, when you open up a web page, do you really know where the information is coming from? The information you see that appears on your screen, some of it comes from a SQL database, some of it comes from text, some of it comes from a whole host of indices, indexes, hash tables, so many things. But to you, it's just information at the end of the day. That's what we have to enable in the world of design and engineering, where we stop worrying, stop thinking about the source in terms of formats and standards and things like that, and really focus on the end result that we're trying to do, which is to deliver information, a continuous stream of information to the right people at the right time in a way that is understandable and consumable by them. That, in some ways, I say today and tomorrow. I actually, there's this famous quote, the future is already here, it's just not evenly distributed. I would tell you that there are many people already working, and I'm going to show you 3 examples in the right-hand side of this particular design or this particular graph, that it's not really tomorrow, it's already here today. And this is the way the people who are trying to address a modern way of designing and engineering infrastructure are already working. Information in the middle, all of the processes and the participants around that, accessing a common set of data, enhancing, enriching a common set of data, consuming a common set of data, depending on their role, their task in the project. What does that look like? So let's take a few of those examples. This is the government authority in Norway that was planning in around this particular village a set of, one particular bridge. And this is a good example of them trying to understand which design would work best for them. And you'll see right now, as the video plays, that they not only looked at different type of bridge designs, they looked at various positions of those bridge designs, they looked at various impacts of those bridge designs before they went ahead and selected one of them. So for them, they were trying, again, from a perspective of involving the public, involving all the agencies, and looking at all the various options that they have in planning this piece of infrastructure. They went through this. Again, you can see that the information on screen to get this model, this is not some cute Hollywood movie or video that I created or people at my company created. This was created by a customer that combined terrain models, SQL databases, GIS information, CAD models, as you can see, to study the various options that they had. So for planning, this kind of BIM for infrastructure technology clearly has a lot of impact. Now let's look at the world of actually designing a piece of infrastructure. This is a dam in China. This I will mispronounce the name, so I will not say it. But here's an example, again, of using GIS information, terrain models, lots of environmental information, and you'll see them doing a bunch of profiling in a second, and at the same time, starting to lay out the actual physical dam in the middle of that river And so they're able to do not just, nice visualization and put pretty pictures that impress people. They're able to do hardcore engineering from where they can derive the amount of concrete, the substructures needed for creating that that particular hydroelectric dam, and drive a process where the information is in the middle rather than the tool being in the middle. That's design and engineering. We talked about public engagement. So here's the thing about that US 101 thing that I talked about all the time. When you're designing a piece of infrastructure, everybody objects to the design that you have because nobody understands what the end result would look like. And so here is an example, again, of a piece of a proposed highway interchange that's being, no, it's not highway, it's just an interchange that's being designed by one of our customers. And the idea here, and they post this to their website, is that anybody in the public who wants to understand what that impact is really going to be can come to their website and see the piece of finished infrastructure, the proposed impact. So when somebody screams and says, look, it's not going to do this, it's going to violate that, you're going to cut down a bunch of trees, I'm not going to be able to see this, see that, they're able to post the exact finished project in a way that engages the public. One of our customers in the Bay Area, Caltrans, did this with the Bay Bridge retrofit that they're carrying out. They had to shut down the bridge for 3 days to put in one of the connections, and they put in an animation that showed the sequencing of how that piece of connective tissue would be put in place. And that really explained to the public why they had to shut the bridge down for 3 days, how they were going to bring it back up, and why they were confident that that piece of connection was going to work. It really made a huge difference in the level of public protests that they saw. They saw very little. It created a great level of confidence. And to their credit, of course, the engineers and the planners on that project actually pulled it off. And the Bay Bridge did shut down for 3 days and reopen exactly on time. There is more that you want to do with the public. So that's one example. And I think you've heard this morning, mobile devices are everywhere. People are walking around with, you all probably have mobile devices right now. Now, how do you engage the public, again, where they are? And this is a prototype. This is not something I would claim that we are offering it's being widely used today, but it will be, which is the ability for the public now to comment. So you can imagine a social network here that uses location as a pivot for people to comment on specific things. There are cities around the world where people are going by and recording potholes. There's an example in Boston where as you drive by, you can basically have this really simple application that reports a pothole in a particular location of the city, and that gets collected by the city, and then somebody eventually prioritizes fixing those potholes. Well, that's one application, and the one that I just showed you is the ability for someone to comment again on something that's being designed, that's being proposed, and have that comment go all the way to the design and engineering team that can then, doesn't have to translate what people are commenting about back to the idea of geospatial technology. You use location as a pivot to understand exactly where in the world their concern lies. I would not be a technologist if I didn't have one of these diagrams in my presentation. So we have to show that all the things that we're describing are very possible. They're very possible. They exist today. There are ways in which all of this information is being brought together. We have many clever people working on creating a service that consumes information from many sources and makes a model like the one that you saw used in the planning and design and engineering examples accessible. Yes, 2 minutes. Okay, and the other thing that I would say is that the internet or the cloud-based environment that we have today contributes to that because it lets us connect information from many places. It lets us apply cloud computing capabilities at the core of that experience and deliver to you this vision, not just for tomorrow, but for today, that we call BIM for infrastructure. that brings clarity, collaboration, and coordination to the largest projects with the largest teams and the largest level of complexity. I believe geospatial technology applied in this way can really start to address that green line, that curve, and bring it closer to the $60 trillion. I look forward to hearing your comments. Thank you very much.